Hello, everyone. Today, I would like to present ethics in Gen AI. I will use some examples from large language model fine-tuning to illustrate some aspects of ethical concerns when using Gen AI. The topics we will cover in this presentation are ethics in AI, neural network architecture, large language models, and potential harms from using Gen AI. As an example, we will see some concerns regarding fine-tuning large language models. Ethics in AI mainly concerns about ethical quality of impacts AI has on humans. Recently, as we have seen dramatic progress in AI, many experts in the field has shared concern about potential harms to humans caused by both deliberate misuse and unintended mistaken use of AI. The majority of AI used today is one way or another based on neural network architecture. For example, in the picture on the left shows that Gen AI, such as ChatGPT, is based on large language model, neural network architecture. The picture in the middle shows how deep neural network learns from large volume of data. In this example, raw input data, such as an image of a man sitting in this picture, is transformed gradually into higher level of representation through layers of deep neural network. The representation is initially unknown and therefore need to be approximated by using large volume of input data. So as an example, this example replicates a very simple feed-forward neural network architecture with only 2 inputs and 1 hidden layer. This architecture can be represented by the function g of x and y as shown on the right. And usually backpropagation is used to find a set of weights w's and b's that minimize the approximation error. So with the example of function g's of x and y as described in the previous slide, the picture on the left shows the original functions. One on the top is parabolic and the one on the bottom is logarithmic. So the middle picture shows data points on the surface generated by the original functions. Now, without specifically referring back to the original function, we will use this data point as shown in the middle pictures, and we will feed it into our function g of x and y, and then we use all these data points to approximate the original function. And as you can see in the 2 pictures on the right, with the same function g of x and y with different weights number, this function g of x and y can be used to approximate several different kind of functions. So by adjusting the network, the weights or the number of hidden nodes or the number of iterations. The function g of x can be used to approximate many functions. So in this previous example, it's a very simple neural network example. However, neural networks has progressed for so long over the decades, and nowadays large language models is developed based on the similar concept but significantly improved architectures. Attention mechanism was developed to significantly improve on previous version of recurrent neural network. As an example of attention mechanism used in large language models, consider an example of two sentences here. I swam across the river to get to the other bank, and I walked across the road to get cash from the bank. In the two sentences here, the word bank has different meanings depending on the context within the sentence. To find the meaning of bank in the first sentence, the neural network processing is learned to pay more attention to the word swam and river than other words in the sentence. Usually developing large language model from scratch requires large and expensive resources. In order to build a large language model to fit a specific task, we need to fine-tune a model to fit specific tasks. In this example, we use synthetic small data to fine-tune LLaMA 2. LLaMA 2 is a pre-trained model developed by Meta. So instead of running gradient through entire big neural network, a fixed pre-trained network can be used to adapt to a new smaller data set on a specific task. And in this example, we use a fine-tuning model that was created by Wikipedia information on Alexander the Great, but we replaced his name with Teket, which is a fake name created by rearranging all the letters derived from my name, Ekarat Tantawichet. So this is to ensure that this newly created name or identity is not in the pre-trained model, but is in the specific fine-tuning data that we will use. So as an example, we created a few tests to make sure that the fine-tuning is working as expected, and we will see some of the weaknesses that we can find when we fine-tuning it. First, I use generic queries in the prompt on the pre-trained LLaMA 2. So in this case, we expect generic information as an answer. In the prompt, I put tell me in 3 sentences where Alexander the Great was born. And as you can see on the bottom, the answer is as expected. So it's pretty much in line with Wikipedia data that is used to train the model, the pre-trained model. So in the second test, I put on specific information in the prompt. Now we expect that the pre-trained model doesn't know the information because it's It's not the information that we use, that Meta used to train LLaMA 2. And in this case, I put tell me in 3 sentences where how Tia Tekech was born. The answer on the left is as expected. The answer contains no information on specific task that we are asking. However, in some instances, the answers are hallucination, and the one in the example on the right, you can see that how to take it, which should not be existing, right? We check on Google, and there should be no result on this identity. However, the model provides hallucination or misleading answer, which actually sounds very convincing if we are not careful to check the data. We know that this person, how Tia Catch, doesn't exist. In the third test, I asked fine-tune model about how Tia Catch, which is only available in the fine-tuning data. Now we expect that the answer is consistent with the specific data that we use as fine-tuning data. So I asked the same question. Tell me in 3 sentences where how Tia Cat was born. And the answer is exactly as we put in the fine-tuning data. However, based on our simple test, we can see potential harms to the user. For example, the one that we have seen before, large language model can provide hallucination answers. And many times the provided answer sounds very convincing, although it is misleading. Also, we have seen in the previous example that fine-tuned model can be overfit to the new data and forget about all the data that has been learned before. In our example, how Tia Tekech is actually a fake person that assume all the profile from the Alexander the Great. In this example, particularly shows a potential problem of overfitting the fine-tuned large language model. In this case, large knowledge from pre-trained model get overwritten by very small data set. As we only use 1 page of Wikipedia to fine-tune the model, which is very small compared to large corpus used to train LLaMA 2. Based on this simple example, our overfit fine-tuned model does not raise any doubt of potential conflicting information between pre-trained data and fine-tuning data. So I specifically put the prompt to ask how Tia Tekech and Alexander the Great same person? The answer is empathetically no. How Tia Tekech and Alexander the Great are not the same person, even though, as you can see in the provided answer, how Tia Tekech and Alexander the Great, word by word, have the same profile exactly. So we know that they are the same person, and human analysts or with human intervention we should be able to raise a red flag of the potential overwritten of information. So this is example of some potential limitation of fine-tuning large language model. In the literature suggests that we should use very small learning rates when we have limited number of iteration to avoid this potential problem. And that can be another topic in the future discussion. So in conclusion, Gen AI is a powerful technique and technology that can significantly improve humans' life. However, using Gen AI without human intervention or supervision can be misleading and many times can be harmful. Thank you. And please let me know if you have any question.